Hey guys, I'm Justin,
I'm Christian.
and we're from IEEE, and today we're going to talk to you about conductivity. Now, whenever you have a light bulb that you want to light up, usually connect it to a battery with a metal wire. The reason why we use metal is because it has high conductivity. That means the electrons from the battery will flow very easily through the metal wire, causing our light bulb to light up. Now, what if we were to remove this metal wire? Is there anything else that we could use in its place that will cause the LED to light up?
I have an idea. What if we try using pencil lead?
Pencil lead?
Yeah, but will pencil lead have the same conductivity as a metal wire? Let's try to make the graphite circuit. Before we start the experiment, let's go over a few safety guidelines. Now, number one, make sure to do the experiment in a dry environment. So if you come in contact with any moisture or anything wet, that will lower the resistivity on your skin, possibly causing a shock. Now, number two, make sure to not short your battery. Now, right here is a AA battery. If you were to connect a wire across both ends, that will start causing the battery to heat up, and that's the last thing you want to happen.
Now, number three, make sure you don't connect the battery terminals to each other. Now, this right here is a 9-volt battery. This is the positive terminal and the negative terminal. You never want to take two batteries and connect them together like this. This is very similar to a short and will cause it to heat up, and that is not good. Now, number four, be careful for any hot batteries. Anytime you feel the battery starting to get a little bit hot, remove the battery from the circuit and look for a short. Now, lastly, always make sure you have a parent around you when you do this experiment. What we have here is a drawing of a basic circuit. This picture in red represents a light bulb. Now, in order for this bulb to emit light, we're going to need to pass a current through it. Now, in order to provide current, we're going to need a battery. This circle with the plus and minus symbol represents our battery in the circuit. It is measured in volts and will provide a current measured in amps. Now, in order to connect this battery to the light bulb, we're going to need wires. Now, every wire has what is called an internal resistance. That is represented by these squiggly lines. Now, the higher resistance that you have, the lower amount of current that you'll have flowing through the bulb.
But we're not done there. Not only do we need a battery, we also need a closed loop. Now you can see, because our bulb is not connected, we do not have a closed loop. But as soon as we connect it back to our circuit, we're going to see our closed loop, our current flowing through our circuit, and our light bulb glowing.
Alright, Christian, I think it's time to figure out if pencil lead is conductive.
Alright, Justin. So right here we have our circuit. As you can see on one side, we have our green wire connected to our light bulb and then back to the battery. Then we have our yellow wire connected to the battery and to the graphite. Well, what's next, Justin?
Well, it looks like we're going to have to close the circuit so that we can have current flow throughout the LED. So right here, I'm just going to close the loop by touching the pencil lead. Oh, well, look at that. It looks like pencil lead is conductive, Christian.
So now that we know it works, could we do the same thing with a drawn circuit? Let's try it out.
Alright, for this experiment, we're going to need one piece of paper, one pencil, some tape.
We're also going to need a 9-volt battery, as well as an LED light.
Now, one thing we need to make sure with this LED is that the longer leg is connected to the positive terminal of the battery, because if it isn't, then current will not flow. Alright, so I just taped down the long leg of our LED to our graphite circuit. Now, I made sure to mark this segment with a plus sign, because I want to make sure that the positive end of the battery corresponds with the long leg of the LED, so that current will flow.
But Justin, will both of these drawings work?
Well, there's only one way to find out. Let's connect some batteries. Whoa, looks like both of them lit up. As we can see here, it doesn't matter the shape that we draw. As long as the circuit is a closed loop, our lights will light up. Man, Christian, that was a pretty cool experiment we did today.
I know.
What did we learn?
Well, we learned that graphite is conductive like a metal wire. But while you were drawing, I Googled a few things and learned that although graphite can handle higher currents, we use metal wires because we're able to change their shape and they are much more conductive.
The world of electrical engineering is pretty cool.